just look at the sheer, overwhelming beauty of the Veil Nebula. I mean, when we point our telescopes at the night sky, it's so easy to just get lost in those brilliant colors and sweeping filaments of gas. But behind all those stunning visuals lies one of the most fascinating cold cases in modern astronomy. So today, in this explainer, we're unraveling a cosmic detective story centered right here on one specific, spectacular piece of the celestial puzzle, Caldwell 34, better known as the Witch's Broom Nebula. We are going to explore exactly how astronomers finally cracked a centuries-old mystery about this stellar remnant.
Okay, let's dive into this. We're looking at the broader Cygnus Loop, but I really want to draw your attention specifically to the western edge of the Cygnus constellation. That sweeping, intensely bright arc of gas is Caldwell 34, officially cataloged as NGC 6960 and affectionately called the Witch's Broom. It's an absolutely iconic structure, made even more famous because it is spectacularly photobombed by that incredibly bright foreground star right in the middle of it, 52 Cygni.
Now, humanity has been marveling at the Witch's Broom for quite a while. It was actually first discovered by the legendary astronomer William Herschel way back on September 5th, 1784. So for generations, observers have mapped its delicate threads of glowing gas. But here's the wild part. Even though we've literally been staring at this stunning supernova remnant for well over 2 centuries, it harbored a massive scientific secret. For the longest time, it refused to give up one fundamental piece of information. We knew what it was, right? The shattered remains of a massive star that exploded. But where exactly is it? It sounds like such a simple question, but in astronomy, distance is everything. You absolutely cannot measure the true physical size of a nebula, and you certainly can't calculate the explosive power of the original supernova if you don't know how far away it is. Without distance, a small, weak explosion up close looks identical to a massive, unimaginably violent explosion far away.
Which brings us to the cosmic distance problem. Now, what's really interesting about this data is how wildly the scientific estimates bounced around over the decades. I mean, trying to figure out the distance to the Cygnus Loop and Caldwell 34 was a massive headache for the astronomical community. In 1958, Minkowski estimated 770 parsecs, and just as a quick reminder, a parsec is just over 3 light-years. But then decades later, in 1999, Blair's team used models that dropped the estimate way down to just 440 parsecs. And if you go back to Sakibov in 1983, they estimated a massive 1,400 parsecs. Researchers were totally confused. The data was all over the place, leaving our understanding of Caldwell 34 in this weird state of academic limbo. To figure this out, we had to start looking for clues in the debris. To finally crack the case, astronomers realized they had to stop looking just at the expanding gas of the Witch's Broom itself. Instead, they started looking for something incredibly specific, objects physically trapped inside the blast wave. A team of researchers led by Robert Fesen started hunting for background stars that might actually be sitting directly inside the supernova remnant, and they found 2 prime suspects. There was an M4 red giant star named J205601 and a B-type star named BD plus 314224. By using narrow passband images, the researchers made an amazing discovery. These specific stars had faint, bow-shaped nebulosities around them. Basically, the solar wind coming off these stars, their stellar mass loss material, was physically colliding with the supernova's expanding shockwave.
And this brilliantly illustrates the exact proof they needed. In a deep exposure of the northwestern limb near that B star, you can actually see the physical blowout happening. The expanding shock front of the supernova is becoming visibly distorted, curving and twisting right where it hits the star's stellar winds. This visual evidence definitively proved that this star wasn't just hanging out in the foreground or the background, it was physically trapped inside the expanding debris of the supernova remnant.
So, are these stars our ultimate cosmic anchor points? Think about the logic here. If we have a massive cloud of gas whose distance we don't know, but we find a specific star sitting right inside of it, what happens if we figure out the distance to that star? Exactly. If we can use modern satellites to measure the distance to these interacting stars, we can finally lock in the distance to the entire nebula, including Caldwell 34.
And that breakthrough finally confirmed it is 2,400 light-years away.
Let's see how this all builds up. The major breakthrough to solve this centuries-old mystery finally came courtesy of the Gaia DR2 satellite mission, which was busy mapping the exact positions and distances of millions of stars in our galaxy. By turning Gaia's incredibly precise instruments toward these specific interacting stars, researchers were able to measure their stellar parallax. Parallax is a direct geometric measurement of distance based on the Earth's orbit around the Sun. So for the very first time since Herschel discovered the witch's broom in 1784, researchers had a truly rock-solid number anchoring the gas cloud to a specific location in space.
The measurement came back, and Fesen's team published the hard data. The center of the main shell of the Cygnus Loop is anchored at exactly 735 parsecs away, give or take a tiny margin of error of about 25 parsecs.
So the crucial point is, how does this translate into terms we use every day? 735 parsecs converts firmly and finally to 2,400 light-years, meaning Caldwell 34, the beautiful witch's broom we saw at the beginning, is exactly 2,400 light-years from Earth in the Cygnus constellation. After hundreds of years, the debate was finally settled.
And now that we have this exact distance, everything else just falls into place. The math suddenly works. Knowing it is 2,400 light-years away allows us to calculate the true, staggering size of the supernova's blast radius across the sky. The main shell has a massive linear diameter of 37 parsecs, which is roughly 120 light-years across. It is literally a colossal bubble of destruction. But there was still another mystery to solve, involving hitting a cosmic wall.
You see, distance and size are really only half the story. We also needed to uncover the violent physics that gave the witch's broom its iconic, sweeping, compressed shape. I mean, why does it look like a broom at all? For years, there was an old theory that the original star blew up inside a pre-existing wind cavity, basically a bubble it had blown out itself before dying. But a multi-wavelength composite combining X-ray, UV, and infrared data proved that old theory entirely wrong. The supernova didn't explode in a special cavity. It was actually just expanding through a naturally empty, broad channel located far off the main galactic plane. It was freely expanding into empty space, until, suddenly, it wasn't.
Let's walk through the mechanics of the nebula chronologically. Step 1. A massive star undergoes a core collapse supernova, unleashing an unimaginable amount of energy. Step 2. That spherical blast wave travels easily through the relatively empty, low-density channel we just talked about. But step 3 is where the magic happens. On its western edge, that expanding wave violently impacts a literal cosmic wall, a dense molecular cloud. You can clearly see that exact dense molecular cloud in the UV and dust data. When the supernova's blast wave slammed into this thick wall of dust and gas on the western edge, the shock wave rapidly decelerated and compressed. That violent collision caused intense dust destruction and created the incredibly bright, tightly compressed, sweeping filaments of Caldwell 34 that we see today. So the witch's broom isn't just peacefully floating out there, it is the visible wreckage of a spectacular cosmic car crash.
It really is a masterpiece of destruction.
By combining precise distance measurements with modern multi-wavelength imaging, we have completely rewritten the biography of this object. Let's just summarize this epic journey for a second. From William Herschel's initial discovery in 1784 through decades of deep scientific confusion over wildly different distance estimates, our modern high-tech measurements have finally given us the complete picture. By tracking down interacting background stars, we now know for an absolute fact that Caldwell 34 is 2,400 light-years away. It belongs to a massive shell 37 parsecs wide, and its iconic shape is the direct result of an ancient blast wave hitting a dense wall of interstellar dust.
It really makes you look at the night sky differently, doesn't it? The beautiful, delicate structures we photograph are actually the result of unimaginably violent, unseen forces. If a hidden wall of dust could shape the witch's broom so perfectly, what other invisible cosmic walls are out there, shaping the universe right in front of our eyes? Keep looking up, keep asking questions, and I'll catch you in the next explainer.